Okay, so we've looked at the accuracy and precision lab, and now we're going to look at how to fill out a lab report. Along with labs, you either are given a paper copy or a document that shows you that you fill out with the lab so that you can, this is what you turn in for points. A lot of kids get confused because they say, well, I was here and I did the lab. If you do the lab, but you don't write up your results and analyze them, it makes no difference. It does no good. So this is the important part of the actual lab when you're interpreting your data. So we'll have a title on it, and then we'll have a purpose to determine the difference between accuracy and precision in an experiment. And sometimes there's some pre-lab. It could be some definitions. It could be doing some calculating or making a data table. So I've gone ahead and I've already marked these out. So define accuracy, how close our measurements are to the target, and precision is how close our measurements are to each other. So it's important that we distinguish between those. Then we have our hypothesis. I went ahead and put this in here because we've already identified it in the Nearpod that we did. If the target is closer, then the drops will be more accurate. Normally you have to write a hypothesis as to what you think is going to happen, and then you discuss that in the conclusion. So we have our materials here, we have our procedures that we've already looked at, and we have our data. I just simply copied this data over from the Google Sheets that we showed you in the Nearpod. And then we have to make a graph. So you'd have to take this data and make a graph in Google Sheets and then copy and paste it in here, which this is the graph that we made in the Nearpod. And a lot of times there's analysis questions that go along with a lab. In this case, there are a handful, and it just asks you to interpret the data that you're given. So in this case, what is the independent variable? It's the distance the thrower is from the target. The dependent variable is the distance the cotton ball is away from the bullseye. What two variables did you keep the same? There are answers that we could use. More than just this answer is correct, but I said the target is the same each time and the cotton balls that we use are the same. So now it's asking you to interpret your data. Who is more accurate in part A? Explain with data. Well, Mrs. Fishbach was actually the most accurate in part A, being an average of only 5.59 centimeters from the target. So she was the closest overall to the target. And then it says, who was more precise in part B? Explain with data. Mr. Moe was actually more precise because overall his cotton balls landed closer to the target, thereby closer to each other. What two human errors could have affected this experiment? I actually named off 3, but there could even be more than that. Not throwing well, being off balance, or not measuring accurately are some examples of errors that we could have. What could you do to make this experiment better? I said have more throwers or throw more trials and throw for more trials. And then it says explain why you want to be both accurate and precise in taking measurements in an experiment. We need to be accurate to get our measurements as close to the desired target as possible. Precision verifies our results by being similar. It shows we can repeat our measurements. So we do, in fact, need to be accurate and precise when we're in lab. The last thing I ask you to write is a conclusion. And the first thing we need to do in a conclusion is accept or reject our hypothesis. In this case, our hypothesis read, if we look back up here, if the target is closer, then the drops will be more accurate. Well, Mr. Moe in this case was kind of an anomaly. He was actually more accurate from 2 meters than he was from 1 meter. So I have to reject my hypothesis because when the target was closer, Mr. Mulholland was less accurate. The next thing you need to do is describe it with data. So our data shows at 1 meter away from the target, Mr. Mulholland throws were an average of 6.27 centimeters away from the bullseye. When we moved to the target 2 meters away, his throws were an average of 4.44 centimeters away from the bullseye. So the first sentence in a conclusion is always, I accept or reject my hypothesis. Your next sentence is going to tell me why using data. I don't give you all of my data here. Mr. Mulholland is the one who kind of messed up our hypothesis, so I'm only going to talk about his data and how it affected our results. The last thing that you need to do is give 2 potential errors. You need to make sure that these are like legitimate errors. Your lab partner is not an error. And you can't possibly have an experiment where there are no errors possible. It's not saying that these occurred, it's just saying these are potential errors. And in this case, I chose 2 errors could have been that could have impacted our results were Mrs. Fishbach had 2 throws that did not land on the paper target and chose to rethrow to get closer to the target. Additionally, mistakes could have been made eyeballing the center of the target while measuring. So it just means that we could have measured slightly wrong. So this would be, as it's written, 100% for a lab report.